Here's a question. What's a gyroscope? Is it a toy or space-age technology? Well, it's both, and more. It's in toys like frisbees and spinning tops. It helps ships find compass directions. It helps pilots in planes keep the plane stable. And yes, it is in space stations, like the International Space Station. So what's so special about gyroscopes? It's angular momentum. First, let's look at linear momentum, which is objects moving in a straight line. Newton's second law states that if you have a mass and you apply force to it, it will keep wanting to move in that direction that you apply the force to, unless some other force tries to stop it, such as gravity or friction. Here I have a soccer ball. Let's give it a kick and see what momentum it has. Linear momentum is mass times velocity, or P equals m times v. Angular momentum is very similar. It is the movement of mass in relation to a point, we often call the axis. We can measure this by adding in the radius, the distance from the mass to the point. So the formula is mass times velocity times the radius. With a soccer ball, you can see the direction of the momentum. With this, it's a bit harder, but we can find it using the right-hand rule. If we follow the mass with our fingers, our thumb will point in the direction of the momentum. This means that this axis wants to keep pointing in this direction. This is why a spinning top does not want to fall over, because the momentum keeps it pointing upwards. And if a force such as gravity tries to pull it down, it will resist and fight back and try to pull it up again. This is the amazing bit that you don't want to miss. If I hang this wheel up by a string, what do you think will happen if I let it go? Well, we all know the gravity will pull it down, but if I add angular momentum, then this axis will want to keep pointing in this direction. So, which force will win? Let's have a look. Wow, it's not falling over. We all know the gravity trying to pull it down, but now we know that angular momentum is keeping this axis in the same direction, and the fight between the two forces is causing this spinning of the wheel, which is called precession. I could watch this all day. This is still amazing. Here's our gyroscope. The axis is pointing in the direction it started and is defying gravity. You can do this in your own home, even without a gyroscope. All you need is a spinning top, which most of you would have played with when you're younger, and it uses the same principle. The direction of angular momentum of this top is through the axis, and the momentum is resisting the pull of gravity. Here I am in a chair. If I tilt the wheel, momentum moves me. If I tilt it back, it moves me back. The International Space Station has 4 giant gyroscopes, and if they move one, the whole ship moves, so they can point it in whichever direction they want. Gyroscopes really are toys and space-age technology, and they really are amazing. I feel like I'm in a gyroscope now. I can feel the axis turning, I feel the mass, I feel the velocity, I feel